talking about scientific notation. All right. And scientific notation is very useful. We use it all the time in our science classes. And so we are going to be learning how to use scientific notation this year. And so we'll be learning a little bit on each little unit here, how to work with scientific notation nice and easy. And so we use it to represent really big numbers and really small numbers. And before we move on to that, I want to talk about what we've been learning with our exponents. All right, what is 10 squared? And again, when I write stuff down, you should write stuff down too. What is 10 squared? 100. It is 10 times 10, which is 100. What is 10 cubed? 1,000. Yeah, it's a 1 with 3 zeros. And what is 10 to the 4th? A 1 with how many zeros? 4 zeros. 1, 2, 3, 4. Okay. So what happens when we take 10 and raise them to big powers like that? What kinds of numbers do we get? Big numbers. Okay? And you can imagine that 10 to the 8th would be what? A 1 with 8 zeros. That's exactly right. 1, 2, 3, 4, 5, 6, 7, 8. Okay, huge, right? It's a lot easier to write 10 to the 8th than a 1 with 8 zeros, isn't it? Okay. So when we have these positive exponents, of course, and 10 to the 1st is only 10. When we have these positive exponents, we get very big numbers. Okay? So what happens? What is 10 to a power of 0? 1. Oh, very good, very good. Okay. What is 10 to the negative 1? What? Is it happy or sad? It's sad, so it converts to 1 over 10 to the 1st. And what is 1/10? What decimal is that? 0.1. Oh, and what is 10 to the negative 2? Very good. It is 0.01. Remember, happy or sad exponents here? Sad. So it becomes 1 over 10 squared because it's sad up here in the numerator. It wants to go down to the denominator. Well, that becomes 1 over 100 or 1/100th. And what is that decimal? 0.01. All right. What is 10 to the negative 3? Yes, 0.001. It is 1/1000th. And 10 to the negative 4 is what? 0.0001. Okay. And so what happens? So let's check. I just want to be sure I got this right because you never know. Oh, look at that. What did my calculator do? That's an E thing. That's kind of weird, isn't it? That's the calculator's notation. That is scientific notation. Yeah. So it's just using scientific notation instead, which is okay. It's kind of weird, but that's okay. So it is using that exponent. That's what that means. That exponent of -4. All right, so we get what happens when we have exponents that are negative. What kind of numbers do we get? Very, 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 very small. Very, very small decimals. Okay, really little. And that's something that I think makes understanding scientific notation a lot better. Okay, when we have positive exponents, we're getting very, very big numbers. When we have small negative exponents, we're getting very, very small decimals, okay? So what we're going to do for scientific notation is a compact way of writing very large or very small numbers. Okay, sorry, you can see that. Is a compact way of writing very large or very small numbers. A number written in scientific notation has a form of a times 10 to the n, where a is a number greater than 1, greater than or equal to 1, but less than 10, and that's very important. So we could have something like 9.2 times 10 to the third, where a, that is less than 10. That works. Could I have 23.2 times 10 to the second? Could I have a number in front that's 23? No, that doesn't work. We have to have only a single integer right there in the leading decimal, okay, in front of the decimal. Okay. All right. This is for directions. I'm going to come back to those, I think. Let's write each regular standard number in the scientific notation. So what we want to do is we want to say, hey, is this a big number or a small number? It's a big number, okay? So it's a big number. My exponent should be a positive number, okay? And then I need to know, where should I put the decimal? Right now, my decimal is over here on the right side of 540. Yeah, so this decimal needs to move between the 5 and the 4. So 5.4 times 10 to how many exponents? How many places did we move that? Yeah, we moved 2 spots. All right, let's see if I can check it on my calculator. 5.4 times 10 to the second. Hey, look at that. Can you check your answers? Absolutely. Good idea, especially if you're unsure. All right. Again, we have another very big number here. And my decimal is way over here on the right side. And I need to move my decimal. Where does it need to go? Between the 3 and the 9, right there. It's got to move that far. So my leading number here, the A, is going to be what? 9.37 times 10 to what power? 5. Let's see. 1, 2, 3, 4, 5. Yeah. Great. All we're doing is relocating that decimal. All right. So again, my decimal starts on the right-hand side, and I got to move it way over here between the 1 and the 8. So I'm going to have 1.852 times 10 to what power? Yeah, let's see. 1, 2, 3, 4, 5, 6. That is fantastic.
This is good. Now, would you like a snack?
Oh, okay.
You're ready to do well. It is little or as you want. So you take more than one item.
Ooh.
Lemonade with sparkling water.
Nice. Cool. I love free stuff. Thank you. Great. Okay. Fantastic. Let's take that decimal and move it between the 7 and the 6. All right, that's going to be 7.6820 times 10 to what power? 4. Very good. And again, maybe we don't know. Maybe I'm not sure. Can we check our answers? 7.6820 times 10 to the 4th. There we go. 7, 6, 8, 20. Hey, that looks perfect. Okay. So check your answers. That is just great. Let's skip here. Let's go down to number 6. Number 6. Is this a big or a small number? Small numbers. So these are very small numbers. All of these are very small numbers. And so if it's a very small decimal, what kind of exponents are we going to have? Negative exponents. All right? So negative exponents are what we're going to have here. We had positive exponents on big numbers. Does that make sense to you? I'd rather think about things like that. Positive exponents give us very large numbers. Negative exponents give us very small numbers, okay? All right, so once again, I have a decimal, and I need to relocate it so that I get a value, a number less than 10. All right, so I got to take this decimal, and now I got to move it over here between the 9 and the 8. So I'm going to get 9.82 times 10 to what power? 3 or negative 3? Negative 3, because again, we have a small number, so we're going to need negative exponents. Let's see if we're right. So again, I'm going to type in my scientific form here. 9.82 times 10 to the negative 3. And I get 0.00982. It's a match. Okay. Let's see. Let's do number 8 here. Where am I going to move my decimal? Between what? The 1 and the 4. Very good. So I'm going to get 1.4 times 10 to what power? Negative 6. Think bunny hops. 1 hop, 2 hop, 3 hop, 4 hop, 5 hop, 6 hop. So negative 6. Count carefully. This is where mistakes happen in counting. Counting is so hard. It takes so long to learn to count when you're a baby. So every kid counts the same way when they're little. You're like, maybe 12 months old, you maybe start talking and counting a little bit. So they all go, you get things in a line, you line up those blocks, and what they do is they start at the beginning, they do 1, and then they go all the way to the end, and then go 2. And then they work their way to the middle. And that's how we learn. We take big things, we take the whole group into account before we learn to say 1, 2, 3, 4, 5. It's really interesting. Sorry. Let's look at number 10. My decimal needs to move between what two numbers? 7 and the 2. All right, so that's going to be 7.25 times 10. Ooh, to what power? Negative 9. Very good. Okay. Let's look here. Keep going. Determine if the number is correctly written in scientific notation. If not, correct it. How's number 11 look? Does that look good? Yes, that is correctly written. Let's look at number 12. Is that right or wrong? Wrong. No, that's no good. All right, so it's no good. Why? Yeah, 11 is too big a number. So we need to move the decimal one more place over. All right, so 1.14 times 10. If I move the decimal, it was 10 to the 3rd. Yeah, it's going to increase to 10 to the 4th. This is a big number. Our number is still going to have positive exponents. We're increasing it a little more. What about number 13? Is it right or wrong? Wrong, so that's not correct. And again, the placement of the decimal is not quite right. Ooh, this is tricky. So when we think about this number, this is a small number because the exponent is negative, okay? So I can imagine that this, it says it should be a really small number. I don't know what this exponent needs to be. And one thing I can do is write it out in standard form here. So what I'm going to do is I'm going to say, I know this is a small number, so I'm going to move the decimal to get a lot of small numbers here. So I'm going to move the decimal 5 spaces, 1, 2, 3, 4, 5. So I get 0.000851, 0.000851. So there's the number written in standard form. And so now I need to put it correctly here. My decimal needs to go between what two numbers? The 8 and the 5. Okay. So it should be 8.51 times 10 to what power? Is it 6 or is it negative 4? Negative 4. 1, 2, 3, 4. These can be tricky, but we can always go back to standard form if we want to. So this one, I needed to move to the left one more position, that's going to turn my -5 one less, so it becomes -4. Or I guess it's one more. Weird to think about. Number 14, good or bad? Good, yes, this is fine. All right. Let's try this. Almost in the bucket. That's why we have tests in there. All right, converting to standard form is easier. The exponent tells you the number of places to move the decimal. All right. So when I look at scientific notation, I have a positive exponent. This tells me what kind of number should I get. A very big number coming at you here. So how do I want to move the decimal place here to make it bigger? To the right, yeah. So we're going to move the decimal 1, 2, 3 places to the right. We're going to get 6, 3, 8, 0. And that decimal is now over here on the right side, and we get a very large number. All right, here, again, we have a big exponent, a positive exponent. So how do I need to move that decimal? I got to move it 5 spots to the right. 1, 2, 3, 4, 5 spaces to the right. Yeah, we're moving the decimal. Whatever that exponent is, we're moving the decimal that many places. So we would get 2, 0, 8, 5. That was 1, 2, 3 spots, and I need to have 2 more places, so 2 more zeros. And now my decimal is over here, right side. How are you doing with this? Is this okay? Yeah? All right. What about 9.82? I need to move the decimal how many places? Yep, just move it 1. Move 1 place to the right. And so what does my number become? 98.2. Very good. All right. How many places do I need to move on number 18? 6 places. To the right. Hello? Ooh. You're all middle school.
8th graders wearing red.
Nice job.
And then 7th graders wearing red. 1, 2, 3, 4, 5.
Thank you. All right. So I have, on this decimal, I have 3 places. So I'm going to move those 3 places. And then I need 3 more zeros to move 6 places. All right. Let's get down to number 20 here. These have negative exponents. What kind of number does that create? A little number, little small numbers. So negative exponents are going to tell me, before we were moving everything to the right, these are going to move to the left to create a smaller number. So 1, 2, 3, 4, 5 spaces to the left, and I got to fill in all those little hops with zeros. So point 0, 0, 0, 0, 0, 0, 0, 0, 5, 2, 5. What about number 21? What does the -1 tell me to do? Left one spot. So just move that decimal left 1. That's going to give me 0.7932. What about number 22? What's that -7 tell us to do? Left 7 spots. So again, 1, 2, 3, 4, 5, 6, 7 spaces. That's a lot of zeros. How many zeros are going to fill in there? 6 of them. So point 1, 2, 3, 4, 5, 6 zeros. And then 162. That is a very small number. Does anyone have any questions on this? Raise your thumb if you're good. You good? Yeah? Okay. Cool. All right. Let's see. Let's place it greater than or less than in the circle to complete each statement. I have a question. If this is 10 to the third and this is 10 to the fifth, which one's bigger? 10 to the fifth is absolutely bigger. It's got 5 zeros instead of 3 zeros. Which one's bigger? 10 to the 7th or 10 to the 4th? 10 to the 7th is absolutely bigger. It's got 7 zeros. Well, not exactly 7 zeros. 5 zeros. Now we have negative exponents here. Think about your number line. Think about your number line. Which one's actually larger? Negative 2 is larger than negative 3. On our number line, the numbers to the left are larger. So that exponent of negative 2 is going to give us a larger answer. All right. At number 28, again, look at those exponents. You think about your number line. Negative 6 is here. Negative 1 is there. 0 is here. Which one's larger? The negative 1 is farther to the right-hand side. That's going to always give us a larger value. Cool. All right. Are you ready for delta math?
Yes.
Yeah? Okay. I think that's good. All right. Super duper. Ooh, 21.